So for the magnet fluid or the ferro fluid, this experiment did work. It did take me a couple times to kind of like get the ratio right, but I did get it. There's a picture if you look closely, you can see like the little spikes. Um, from my experiment, and this experiment was probably my favorite one. Um, I don't really know why, but it was really cool because in the video he had put some of it on a table and he was like touching it and kind of playing around with it. And so I experimented with that a little bit. It was kind of it was just something really different and kind of like a little kid experiment, and I loved it. Um, so for the actual experiment, um, we just made a magnetic fluid. We took laser jet toner, vegetable oil, and a rare earth magnet, and I poured the toner into a cup, and then I poured vegetable oil into that same cup, and that was the ratio that I just got done saying that I was trying to um, get the correct ratio. In the video, he kind of said that you might have to pour more vegetable oil in it just so you don't make it super thick. And so I kind of played around with that, and then you stir the toner and the vegetable oil until it's consistent. And then I transferred it into a smaller container so that it was easier to work with. Um, so to test the fluid to see if it's like magnetic and the perfect ratio, you put the earth magnet on the bottom or like on the side of the container, and if it is done correctly, the little needles those needles right there in that picture, if they pop out, then it's done correctly. If not, your fluid or ratio is either too thick or too thin. And so then if it's too thin, you just need to add some more vegetable oil in. Um, like I said earlier too, you can touch it, spin it around, play with it, do whatever you want with it. It's really cool. Um, so I actually did that too. I kind of just followed around with the video that was on Blackboard. Um, if you pull the magnet off, the it immediately goes back into the liquid. So the spikes that like pop up if it's done correctly, the spikes will go away and it immediately goes back into your mixture that you started this whole experiment with. Um, so just a little bit more about like the fluid mixture and the magnetic and how this all works. The ferrofluid is one of the neatest things to see in action, which is definitely true. Um, so like all it is doing is suspending the liquid through the use of magnets. The ferrofluid is a suspension of ferrous, which contains iron and a liquid. So right there, taking the magnets and trying to get the spikes to show at this given point the mixture was too thin, and so I added more vegetable oil to it. Ferrofluid is made up of tiny magnetic fragments of iron that is suspended in oil with a surface to prevent the clumping. The surface in this experiment, well, in that picture was the glass. And then when I played around with it and touched it, I put it on, we have this like kind of like a glass table. Um, but the glass isn't super, it's not like one of those super thick tables. Um, so I actually just poured the fluid onto the glass and then I put the magnet underneath it and it did the same thing. And so the glass was that surface that prevents it from really clumping. And then that's why like when you take the magnet off, it immediately goes back into that liquid. Um, Many commercials applications for ferrofluids. Even though we don't know it, we see it a lot on TV and commercials. Only or oily fluid prevents debris from entering hard drives when a small amount is placed between the magnets and the shaft, which I thought was kind of interesting that after doing this experiment, when you see like those little spikes and stuff, that to put this in a hard drive to help prevent debris getting in, kind of is mind blowing to me. So you just pretty much picture this experiment as a magnet. The ferrofluid changes shape in response to other magnets, and that's why um, it like has a spike to one magnet. It's useful in creating seals and computer parts, like I just got done talking about preventing debris to get into the hard drives. Um, the magnets inside hard drives are used to hold the ferrofluid in place. This creates a tight seal to prevent dust from getting into the hard drives. And then because the ferrofluids are a liquid, their use eliminates friction during rotation of the hard drive disks. So, after I did a little bit of research, I found out that the ferrofluid is really mainly used a lot in hard drives, which, like I said earlier, this whole experiment was kind of like really cool and mind blowing to me. And that's it.